a flexible framework for experiencing cutting-edge LLM inference fine-tune optimizations. Overview. Ktransformers is a research project focused on efficient inference and fine-tuning of large language models through CPU-GPU heterogeneous computing. The project now exposes two user-facing capabilities from the KT kernel source tree: Inference and SFT. Updates. June 21, 2026, Minimax M3.0 support. June 17, 2026, GLM 5.2.0 support. May 6, 2026, Ktransformers at GOSM Paris 2026 Agentic AI on Edge Track will present KT's inference performance on consumer hardware. May 2, 2026, DeepSeek V4 Flash support. April 30, 2026, Ktransformers V0.6.1 refreshes KT kernel inference and SFT docks with separate inference and SFT quick start entry points. March 26, 2026, support AVX2 only CPU backend for KT kernel inference. February 13, 2026, Minimax M2.5.0 support. February 12, 2026, GLM 5.0 support. January 27, 2026, Kimi K2.5.0 support. January 22, 2026, support CPU-GPU expert scheduling, native BF16, and FP8 per channel precision and AutoDL unified fine-tuning and inference. December 24, 2025, support native Minimax M2.1 inference. December 22, 2025, support RLDPO fine-tuning with Llama Factory. December 5, 2025, support native Akimi K2 thinking inference. November 6, 2025, support Kimi K2 thinking inference and fine-tune. November 4, 2025, Ktransformers fine-tuning via Llama Factory integration. October 27, 2025, support Ascend NPU. October 10, 2025, integrating into SGLang. September 11, 2025, support Quant3 Next. September 5, 2025, support Kimi K2-0905. July 26, 2025, support Small Thinker and GLM Formo. July 11, 2025, support Kimi K2. June 30, 2025, support 3-layer GPU-CPU disk prefix cache reuse. May 14, 2025, support Intel Arc GPU. April 29, 2025, support AMX Int 8, AMX, BF16 and Quant3 Mo. April 9, 2025, experimental support for Llama 4 models. April 2, 2025, support multi-concurrency. March 15, 2025, support Rockman AMD GPU. March 5, 2025, support Unsloth 1.58 2.51 bits weights and IQ1 SFP8 hybrid weights. Support longer context for DeepSeek V3 and R1 in 24GB VRAM. February 25, 2025, support FP8 GPU kernel for DeepSeek V3 and R1, longer context. February 15, 2025, longer context from 4K to 8K for 24GB VRAM and slightly faster speed. February 10, 2025, support DeepSeek R1 and V3 on single and multi-GPU and 382G DRAM, up to 3 to 28 times speedup. August 28, 2024, decrease DeepSeek V2 required VRAM from 21G to 11G. August 15, 2024, update detailed tutorial for injection and multi-GPU. August 14, 2024, support LAMP file as linear backend. August 12, 2024, support multiple GPU, new model Mixtral 8x7B and 8x22B, support Q2K, Q3K, Q5K Dequant on GPU. August 9, 2024, support Windows native capabilities. Inference high-performance KT kernel serving, CPU-optimized kernel operations for heterogeneous LLM inference. Key features: AMX and AVX acceleration for int4 and int8 quantized inference. MO optimization with NUMA-aware memory management. Quantization support for CPU-side int4/int8 weights and GPU-side GPTQ. Easy integration with a clean Python API for SGLang and other frameworks. Quick start. Change directory to KT kernel and install the package. Use cases include CPU-GPU hybrid inference for large MO models, integration with SGLang for production serving, and heterogeneous expert placement with hot experts on GPU and cold experts on CPU. Performance examples show a DeepSeek R1-0528 model achieving 227.85 tokens per second overall throughput and 87.58 tokens per second output throughput with 8-way concurrency on an 8XL20 GPU and an Xeon Gold 6454S processor. SFT. Fine-tuning with Llama Factory. Ktransformers and Llama Factory integration for ultra-large MO model fine-tuning. Key features: multi-backend support for CPU-GPU hybrid fine-tuning with int8 and int4 quantization, ultra-large MO support for fine-tuning models such as DeepSeek v3 and R1 on limited GPU memory, faster than zero offload with 6 to 12 times training speedup in benchmarked MO SFT workloads, lower CPU memory usage, about half of the previous KT-SFT path for the benchmarked setup, seamless integration with the popular Llama Factory fine-tuning framework. Performance examples show DeepSeek v3 and DeepSeek R1, each running on 4 RTX 4090 GPUs with about 3.7 iterations per second and Qwen3-30B, A3B running on a single RTX 4090 with more than 8 iterations per second. Quick start. Navigate to the fine-tuning directory, install the required packages, and launch training with the provided configuration file for an int8 accelerated setup. Citation: if you use ktransformers in your research, please cite our paper, Transformers Unleashing the Full Potential of CPU-GPU Hybrid Inference for MO Models, presented at the proceedings of the ACM SIGOP's 31st Symposium on Operating Systems Principles, 2025. Contributors and team. Developed and maintained by MadSci's lab at Tsinghua University. Approaching AI, 9 AI Soft, and community contributors. We welcome contributions and encourage the submission of issues and pull requests. Community and support. For support, report bugs or request features on the GitHub issues page. There is also a WeChat group available via the archived resources. KT Original Code. The original integrated K-Transformers framework has been archived to a directory for reference. The project now organizes the two capabilities above from the KT kernel source tree for clearer documentation and maintenance. For the original documentation with full quick start guides and examples, see the archived README files in English and in Chinese.